Okay. Well, welcome everybody to the August 22nd edition of the Technical Advisory Council of the Confidential Computing Consortium. We are an open and collaborative meeting. Everybody here is welcome to contribute constructively. People are welcome to contribute to any of our projects, any of our working groups. We generally gather here because we think that we can all do better as a group, working together to promote confidential computing and making the world a safer place than any of us can do individually or just within our own companies. Because we have a lot of variety of companies here, we also need to make sure that we abide by the Linux Foundation's antitrust policy. So you can read more about that at linuxfoundation.org/antitrust-policy. We have today a very educational agenda. We're going to skip over some of the normal recap in order to get underway with the first tech talk. We have Jiwei Zheng here from Intel to talk about the OPIA project, which is an AI-focused project. And then we might swap things around depending on how we're doing with time. We've got Mingshen on the deck to talk about the TAC goals that he'll be working on, and then we've got the Pandora talk. So I think we might end up swapping those around depending on what Joe's schedule is like. And then time permitting, we want to probably introduce some budget concepts. We're coming up on the budgeting season. We'll want to get that into the next formal agenda probably. And I don't think we've got a slide in the deck for that, but Ben normally has one hidden up his sleeve. So maybe he can sling one in there if we end up with time for that. Is that okay? Okay, see Ben nodding yes, great. Okay, any other agenda topics for today? Okay, well, we're going to skip over formal roll call for the voting members because we don't have a vote today. I do want to spend just a few minutes, though, not skipping over this important part where we let people who are new to the community introduce themselves. So if you haven't introduced yourself at least twice, feel free to pop off of mute and let us know how you like to be addressed, where you're joining from, and what your confidential computing interest is.
Perhaps I can go first. So my name is Chandran Nalugal. This is my first time joining here. My interest in confidential computing is, I have worked on the area of attestation. I contribute to various industry standards, and I'm very much aware of confidential compute. And I've, worked in the area in the background, but not directly with CCC. And my interest here is, I come from the data storage background. My interest here is one, to learn where the focus is right now for CCC. And the second is, I have some ideas on using or percolating down the CCC concepts to data storage such as Keeper IO with NVMe and TCG. I would like to contribute in that area. Those are the interest areas for me. Thank you.
That's great. Well, we're glad to have you here, and I think probably have a lot of good stuff to fill in on those interests that you mentioned.
Well,
you go ahead. Sorry.
Might as well introduce myself for the second time. Then I'm Andre, joining from Google DeepMind in London. And I'm working on Project Oak, which is a project to run verifiably private workloads on trusted hardware, effectively. Run things in on the Google servers and still have something meaningful to say to our end users that no, we're not leaking your data. So it's interesting that one of your topics today will be about AI.
Yeah. So I think a couple of our main focuses are going to be around AI and secure software supply chain or secure supply chain generally. So Oak is of keen interest to many of us here. So thanks for joining.
Continue. My name is Jens Albers, CTO of Frontier X. We are interested in confidential computing because it's an integral part of what we do. We combine asymmetric cryptography and confidential computing for our identity and access management product, where a user's private key basically sits in confidential computing and helps to decrypt, encrypt all data coming to and from this user. So data is protected at transfer at rest and in processing too. And yeah, very much looking forward, and thank you for having me.
Okay, great to have you. That's a great use case. All right, well, with that, I want to make sure that we're able to get over to Joey right away. We are a bit late in the day on his calendar. I promised him we'd get underway within 10 minutes, and it looks like we are right on time. So I am going to stop sharing here and turn the floor over to you.
Okay, thank you, Dan. Hello, everyone. Good morning, good evening. So my name is Zhiwei from Intel. I'm the product manager for OPIA that I'm going to present it to you. Let me just start sharing my screen. Sharing the screen.
And while he's getting that up, I'll just kind of give the preface again that with one of the things that the board asked us to do a few months ago is start focusing more on use case orientation for what we do with confidential computing. And a couple of those main use cases that we just mentioned were AI and supply chain. So this project that Joey is about to talk about is another Linux Foundation project. So there's some potential good synergy there. And we want to look at what we can do with confidential computing to help secure whatever AI stack people are working with. But this might be a particularly interesting one for us, given the affinity with the Linux Foundation. And I can see your slides now.
Okay, cool. Then thank you, Dan, for the introduction. So what I'm going to present today is called OPIA. It stands for Open Platform for Enterprise AI. And it is a project under the Linux Foundation. So it's an open source project, and we're welcoming all the ecosystem members to join force to build open source solution for Gen AI for enterprise. We have open source the code under GitHub repo under this link. And I will share the deck after the meeting to Dan, and everybody will have the deck afterwards. Feel free to reach out in case of technical discussions, use case discussions. This is my email. So I will go ahead into. We want to have a look at the problem statement for today at enterprise in terms of a Gen AI solution. So since ChatGPT launched into the market about 2 years ago, so enterprise AI started building the Gen AI solution to increase their enterprise productivity. Nevertheless, the Gen AI solution is a very complex and a compounded AI solution system. It's not that straightforward. And enterprise need to think about a lot of things when they build a Gen AI solution. How do I make the different AI component together to make it really efficient and performant? Should I use open source solution? Should I use a closed source solution? So how do I ensure my data is secure so that the data does not feed back to the model to make the model intelligent, so that I lose my intelligence on my enterprise data? And how do I ensure that my Gen AI solution is scalable? And how do I measure my Gen AI solution? All these questions all came up into the mind when the enterprise want to build a Gen AI solution. And based on this, then we just launched this OPIA project in May this year. It's about 3-4 months ago. So basically, we want them bring the ecosystem vendor for the Gen AI solution space. No matter you are a large language model provider, you are cloud CSP, your hardware infrastructure vendors, your chip vendors, or the vector DB vendors, security vendors, all join forces together to build open source solution. And OPIA actually, in a one sentence summary, is we're offering the open source AI inferencing microservices and their reference solutions. Basically, we offer a solution that enterprise company can use in an out-of-box experience. And secondly, we prepare microservice IP so that enterprise OEM can just cherry pick based on their need. The overall motivation is to simplify the Gen AI adoption and reduce the time to market. I'll have more details from technical perspective later. Just one page on the top level marketing side, just let you guys know how is since the 3-4 months after the launch, how is the development of from an OPIA partner standpoint. As of today, this is early August, we have about 35 vendors. We have more than doubled since early launch of the ecosystem partners. And we are right now at the 22nd of August. We have already exceeded 40 OPIA partners from a different ecosystem value chain. And also one more news starting from yesterday, besides Intel, who was the only AI chip company offering CPU, AI accelerator, and GPUs, we have AMD also coming on board 2 days ago. So basically everybody, this 40 OPM members as of today, truly believe that open source, the power of open source, that can bring customer more choices for the Gen AI solution. So we have vector database vendors. We have a Hugging Face like a Model Hub. We have the knowledge graph vendors. We have ISVs, OSVs, all these OEMs. So basically all the sectors from the value chain of the Gen AI ecosystem. Certainly we hope to have more from this meeting, after this meeting. To become a member of the OPIA partner is really, really simple. We need a logo of your company and a quote from your company. Why do you want to join OPIA? Then you become a member, and afterwards, we will welcome you to join the technical steering committee so that we can discuss the Gen AI enterprise use case, how to make it more secure, for example, from a security standpoint. And Dan is also leading the security working group at OPIA Group, for example. And this is just example. So we welcome more vendors coming in to learn this new field and to bring your contribution together. And the final target is to make a win-win solution and to make a competitive Gen AI solution to the ecosystem. Okay, then I will go more detail to the product and technical side. When we look at a Gen AI solution, so we will gather the customer requirement, and then we will gather it and implement OPIA component. Component is more like a Lego blocks. So each of the component is actually a microservice, like the embeddings, a vector database. So all these blocks, building blocks, will be used as IP in the final reference solution. So let me go through with you guys one after another. So if you look at a customer requirement, data security, so super important, especially for this group. From AI standpoint, how do I make my data secure? There's a couple of techniques from AI standpoint. I can use RAG, which is pretty popular today. It's a retrieval augmented generation. That's the one. And second, in order to make my data really structured data, and to build a dedicated model, then we can use fine-tuning techniques. Or we can also use a long context window techniques like the Google Gemini. So you have a super long context window. So you don't need a RAG or a fine-tuning. You simply put all your data into the prompts and you get your dedicated response. That's from the AI perspective. Certainly, we also from the security, confidential computing perspective, we'll have more know-how to be added. The customer want the whole solution easy to use so that I can also increase my productivity and reduce time to market. Also, the cost is an important factor. It's not only just the operating cost, number of the IT resources that I can build my Gen AI, but also the production cost. How can I ensure my Gen AI solution can have the maximum number of the token in average so that I have a better ROI and a better performance. What model should I use? Should I use closed source model like ChatGPT or from Anthropic, the cloud, or should I use open source like Llama 3 or Mistral? From user experience perspective, probably text to text is no longer sufficient. We need digital human, we need avatar, and we need a lot of different things to make the entire user experience super good. And how do I evaluate my solutions? Do I support enough the evaluation framework? And also the deployment scenarios. Should I purchase the hardware, CPU, GPUs to build my own data center on-prem to make it super secure? Or should I just keep the data portion of my data on-prem based on the CPU and call the public models on the CSP side, this kind of hybrid side, or I just put everything on cloud? These are all the different scenarios the customer want to consider. And all this portion, we will factor that in when we're building this OPIA from the solution space. On the component, the microservice perspective, so we need to consider the different options for the embedding models, the vector database, retrieval re-rankers, the popular large language models, and also from a multimodality perspective, the vision models. The model serving part, the most popular model serving like a VLLM and the TGI, so that my speculative decoding and also the page attention continuous batching to ensure the best token latency and token throughput. This is super important from cost perspective for AI inferencing. What options do I have for large language model frameworks? Longchain, Llama Index, Haystacks are all considered in the scope of OPIA. Now, besides the graph, we also have the knowledge graph and the graph rack. Beyond the rack, we will also scale to fine-tuning and also in future, the AI agent. In the very near future, the AI agent. And even beyond that, humanoid, embodied AI, humanoid AI afterwards. So all this, we will have the pipeline prepared for OPIA building blocks as a microservice. And then we need to bring all the microservices together into a reference solution. And the key wording here, besides easy to use, we need to make sure the reference solution is composable and configurable. That means the enterprise customer can easily switch and replace the different components as they want. And we will support all the popular use cases like check Q&A, document summary, code generation, code translation, visual Q&A. We have a lot of more in the pipeline. And all in all, we need to make sure it is easy to use. Below here, it is example. How do we want to make sure it is easy to use? And one scenario, it is a no-code, low-code scenario. So that Intel will also open source this solution probably in early October. So what we want to do here, the customer can select the different building blocks on the right-hand side. They can select the different use case, different building blocks. And eventually they can just swap the different building blocks and microservice. For example, I don't want to use the vector database from Redis, but I want to use it from Pinecone. I want to use another embedding model. I want to use another large language model. So customer can configure and select eventually, and they will see the system matrix and an evaluation afterwards so that they can compare and make their decision afterwards. This is a nutshell, a short summary of what we want to do. We have a more detailed example in the next page. As we said, RAG is an important solution to ensure the enterprise data to be secure. And this is an example showing what we want to do with RAG. This is just intention to show how complex just to build a RAG solution for enterprise AI. And the entire architecture is actually pretty straightforward from use case perspective. When a user wants to send a query to the Gen AI solution, embedding model will convert from the text into the vector database. At the same time, the retrieval re-ranker will collect the enterprise data information through the data ingestion. And we combine the two information, additional context on top of the user query. We will send it to the large language model. And afterwards, we will check the hallucinations through the guardrail. And then user send it back to user. User can give more feedback through the alignment, SFT and RLHF, to make the entire system more intelligent. So each of this dashed line is a building blocks / microservice in the OPIA architecture. So basically, to build a rack system, we may need 7 to 8 different microservice together. We can make it far more complex. This is very high level. So just give us a high level overview how complex a joint AI solution could be for enterprise AI, and who may not necessarily have that sufficient AI knowledge. Therefore, what we want to do in general is to make it simple, to make it useful. Entire OPIA core content, we have two fundamental pieces for OPIA from technical standpoint. We have a construction piece and we have an evaluation piece. So construction piece is how do we implement and build Gen AI solutions. So we have a different set of building blocks like the large language models, vision models, embedding models, vector database, rankers, processing for the prompt, and so on and so on. And also from the use case perspective, how to make sure that you have the entire end-to-end solution for AI agent, and you have all the end-to-end building blocks for the Gen AI flow, and the sufficient tools for the fine-tuning and customizing your data, optimizing your data, and for fine-tuning. And also, all in all, this is how do we build a Gen AI solution from the construction part. Once we construct the AI solution, how do we know this AI solution is good enough? Then we have the second piece for the evaluation. So providing the framework and also the matrix to evaluate the solution from the performance, feature, trustworthiness, and enterprise readiness perspective. And we also have the idea to offer certification. So in a nutshell, we have a construction piece and we have an evaluation piece. Both pieces will be factored in the detailed roadmap in the next page. And this is the roadmap we just revealed with the technical steering committee at OPIA a few weeks back. So it's a lot of content, a lot of wording, but nevertheless, the overall story is very, very simple. So we started our entire project in May. From May to August, we were concentrated on the most popular use case, which is the rack that we introduced earlier. From May to August, we have the rack implementation done. By end of August, we will have the entire solution for rack ready. After August, in September, we will go to step 2 to focus more on the multi-modalities. So image to video generation, image to text to image generation, and more diffusion model will be supported since September. And in Q4 this year, we will even scale beyond other techniques like the fine-tuning and the knowledge graph. AI agent, as we said earlier, we will, by supporting this more easy, as a first step, single agent as a first step, like the React and the planning execution, and also different tooling for the agent will be supported here. Closed source large language models will also be considered, like the ChatGPT and the Cloud from Anthropic, the most popular one. Also the Graph Rack, increasing traction at the AI space. In Q1 2025, we will be considering the confidential container, confidential computing piece. The specification is still open. We welcome more members to join. The security working group, we need your help to define the specification. From AI use case standpoint, multi-agent will be supported there. Fine-tuning, more complex fine-tuning scenario. And we're closely monitor the ecosystem solution from a long context window perspective. And no-code, no-code solution, so we will offer the Join AI solution. This is from the AI feature use case standpoint. So the storyline is actually very simple. Beyond RAG, we know what the market and the enterprise AI need. So this is AI feature and use case perspective. And on the lower part, I still want to point out is from a hardware support perspective, this is the entire open source. And at the beginning, we have only Intel as the only hardware AI chip vendors. So Intel CPU and Intel AI accelerator Xeon Gaudi were in the scope. Nevertheless, since August, we've been supporting the most popular use case at the CSPs like AWS. So Intel Xeon plus NVIDIA GPU instance, the most popular instance is covered at OPS scope. So it's not just Intel. And by having AMD on board, we won't be surprised. We will be supporting AMD in the Q4 or the Q1 next year. This is the data center perspective. From the client age and the PC perspective, starting in Q4, we'll be supporting the AI PC from Intel x86. Probably we'll have AMD x86 as well. And in Q1, we will also considering to have other AI PCs like the Apple. Their MacBook may also be in the scope. So overall, we will make sure it is a heterogeneous architecture by supporting the sufficient number of the hardware vendors. So this is a short overview for the roadmap. And I have I have two more pages. Very simple. One is the calling for joining forces to OPIA to become an OPIA partner. So we just need a logo and a quote. And afterwards, welcome you to join our technical steering committee and also the working groups, especially for this team. We have a security working group being formulated, and Dan is the lead in that team. And our goal is to discuss customer use case and discuss solution space. As a step 2, after you become a partner of OPIA, we will expect you to bring the contributions. You can bring contribution to the code. Then you can create a PR, and then we will discuss case by case based on either it's RAG, fine-tuning, or specification, multi-agent. This is the code part. And we can also discuss the POC, the custom POC. Or last but not least, we can co-develop the solution based on the market requirement. Feel free to join us. And the last page, it is some more QR code. So more information on the GitHub mailing list, and also our dev website. In summary, we're just 3-4 months old. We are running pretty fast. A lot of industry incumbent has been joining, and we believe open source. We believe enterprise customer need choice to build Join AI solution. Welcome everybody to join us to bring your contribution. And thank you, everyone. Thank you, Dan. I'll see if there's any questions. I'm not sure if I'm over time.
No, you're good.
I'm a bit. Okay.
Yes,
I have one question. What place do you see for software vendors that are not open source in this project?
Basic short answers will welcome you to join force. So our entire approach is open source. Nevertheless, there is also customer use case will require closed source software vendors. Like we said, large language model perspective, we're supporting the OpenAI and Anthropic, and the same applies for the other part of the value chain. So our intention is to solve the customer requirements of software to bring the solution they want, and a closed source portion that we can plug and play into our solution if it is technically feasible.
Mm-hmm. Thank you.
And 2 days, I think maybe last week, we have a security company and want to join force Opia, and it's a closed source security API company. It's called Corsa, and now they are one of the Opia partners who offer closed source solutions.
That's good to hear that. Maybe while other people are thinking of questions, if I could steal the sharing from you, I can kind of give a
Sure.
different perspective on Opia as I've tried to get more familiar with it myself. So opia.dev is the easy thing to remember, but it's all open source. And so to kind of give maybe a developer perspective, if you go into the GitHub, like a lot of projects, there's going to be quite a few different repos. But for me, these are sort of like the main two repos, the examples, and then the components. And so when I was getting underway with this, this project has all of the individual microservices in it. These are the different components. And then I like this illustration because it kind of shows like, all right, if I go grab the embedding service and the retrieval service, but maybe I have my own, like to Ophir's question, maybe I've got my own proprietary re-rank service. I can plug my own thing in there. And then there's a coordinating service. And then all of these services can be composed using, normal container frameworks. There's Docker Compose scripts in here. And for each one of these top level use cases, so let's say I wanted to just do like a chat style generative AI case, there's a chat Q&A service in here.
That's right. That's right. We have a chat Q&A in an example part. This is the component portion. Yeah, you're right.
And so anyway, if you dig through here, it's going to bring you to, you can either grab pre-built containers off of like Docker Hub, I think, or you can build everything from source yourself. And I found that pretty straightforward. But I just like to give people like a starting point as a developer of, all right, which repo do I land on? How do I get started with something? And so hopefully this gives you sort of a more hands-on view of what the project looks like and where to jump in with it. All right, any other questions? Okay, well, if anything occurs to anyone else, Jue had left his email on the first slide that he showed, or maybe you want to drop that into the chat if you like. You can reach out to him, you can reach out to me, or it's a pretty active community. So like a lot of our projects, if you go out to the project landing page, there's connections to the wiki and the mail list and other ways to communicate with other people on the project right now.
I type my email there and I will share the deck to Dan afterwards, where Dan can share to the broader audience. Thank you.
Thanks a lot, Jue. And somebody had observed that there's a Intel confidential block on the slide, so if you can take that off before you send it, that'd be great. Okay, so why don't we jump back into the regular agenda, and then I think we'll have Joe on deck. We'll go through just real quick here the normal intro stuff that we skipped over. So last meeting we heard from Mike Purcell, who's out today, so he can't join us. He's keenly interested in attestation business models and wants to generate some more discussion around that. So this is his starting point for the document, and I think he implied that we may or may not stick with that document or just use that as the starting point for working group discussions. But if you're interested in that, you can add some comments into the document there. We got the Verizon project update. So that project is going well. It was good to get the latest on that. So if you missed that discussion, like everything else, it's in the minutes from last session, or you can watch the recording on YouTube. And then we had a tech talk on runtime attestations. And then we heard from Fritz on the overall goals for what we were going to do with the remainder of the year with these tech talks. And it does look like we've got a rich set of these through the end of the year, as well as other interactions with academia.
If you want the direct prelude, we can also just directly talk about what we're going to do.
Sure.
No, go ahead if you want to do something else first before we go to you.
Next thing is to do some announcements, and then I think we'll be ready for Joe's talk. So is there anything else you wanted to throw in there, Fritz?
No, I just wanted to use this as a overload for you, because it's a perfect transition. But go ahead if you have other admin stuff to do first. Okay.
So we talked about the CFP closing last week. So if you missed the chance to get your talk in, there's still a good list of talks that did make it in. So for those who will be at the Open Source Summit or at Linux Plumbers, this event is adjacent to those. I did have a question from somebody in another community that said, hey, I'm going to be there for plumbers, but I don't have an OSS ticket. Can I get in with my plumber's ticket to your mini summit? And I couldn't find anybody to tell me yes. I do not know how closely those doors are guarded. I hope there's a way for people to interact if they're only there for plumbers. But you might want to look into that beforehand so you don't get surprised. And then the other big event that we have coming up is KubeCon. I think that's November-ish. It's not shown here, but we already have a good list of people who want to make use of the CCC booth. If you've got an open source project through the CCC, you kind of have first priority. This is sort of unofficial, but it's open source projects first, then maybe member companies, and then we can kind of go from there. All right. And that link we've shown, and we did the Opia talk, and I hope I have not been saying your name wrong. I'm not sure if you pronounce it Yo or Joe.
That's
but
perfect.
Okay.
Native, I say Yo, but I understand everything, so it's perfect.
The letter J can be pronounced in many ways in different languages, so sorry about that. Yo.
Perfect.
So Fritz, do you want to do the intros or?
Yeah, so I actually prepared this. So for the first TEE Tech Talk this Thursday, I have truly a treat for you. So I wanted to give this sentence off. That was important to me. But other than that, I just wanted to introduce Jo, who is a researcher at KU Leuven, who has been researching on TEs and nowadays called computational computing for multiple years now, and who has been, I think, one of the big ones in academia in this space. He worked on attacks like LVI, Foreshadow, numerous others, Plunderbolt, etc. And has in the last years moved a little bit also towards defenses. And as we also discussed exactly in this old business 2 weeks ago, last time, it would be nice to hear some more defenses and some more defensive sides from researchers. And so I got you to talk about Pandora, which is a research project we did together while I was still in Leuven, where he was my advisor. And so I'm very happy to have him here to talk about it and discuss it with us. And so Jo, go ahead, and maybe first, I assume you will be happy to take questions during the talk, right? So people can just unmute and directly ask the questions that come up. I will monitor the chat, but feel free to, don't be shy, and feel free to pitch in with a question directly if you have one. Go ahead, Jo.
Thank you so much. I will ask to unshare so I can also share. Let's see. This is the tricky part. Should grab.
That seems to be the tricky part indeed.
It seems very still, so I'm afraid that maybe some video drivers are getting in our way.
Seems to be the case. We can wait a second, otherwise maybe we can move in the other talk first.
I think we'll just end up thrashing if we switch too quickly. So
Oh, yeah, somehow this SEG faulted Zoom, trying to share my window. So I will try again. I'm not sure if there's a trick. Some things I can do wrong, but let's see. Okay, so far so good. All right. All right, you should see my slides now, right?
Very good, yeah.
Okay, great. So yes, as Fritz said, please feel free to chime in during the talk. I would be very happy to make it interactive. Let me also start by indeed acknowledging a number of people. Fritz in the first place. This is a long-running project, and Fritz has been the main person there. I think he will also be very happy to chime in the discussion. So feel free to do that. Let me also maybe just to sort of keep track of the time. What is the sort of expected time for this talk? I can be flexible and improvise more or less, but it's good maybe to know a bit upfront.
So we normally do about 30 minutes with Q&A, and the schedule today is going to accommodate. You could do 30 minutes and then Q&A, or you could do 20 minutes with 10 minutes Q&A. It's entirely up to you.
Okay.
You've got flexibility.
I think we can easily talk an hour about this, so I'll try to sort of stick to the essence then. But feel free to interject if there's a timing concern. Okay, so let's get started. Maybe just to put this a little bit in context, I usually have these slides to sort of say what kind of research we do in Leuven. So I work at KU Leuven in Belgium, and over the I think we're in confidential computing already for a long time, for over a decade, and we have looked at almost all aspects of the system stack. So going from really application level development all the way down to the microarchitecture and everything that's in between, operating systems, compilers, and so on. And this project, I think, fits very well in there and is somewhat motivated by, as Fritz already highlighted, some of the attack research that I've done during my PhD. So just to make sure we're all on the same page, I have this very technical slide about Intel SGX. What is SGX? It's just a fortress inside the processor. Right? That's any type of confidential computing architecture. And we like to use this metaphor because the way you attack a fortress is by sort of targeting its weakest point. And very often it turns out that enclaves can be attacked from software via their interface. And just like you target the gates of a castle, you target the software interface of an enclave. And so you could say that this is the somewhat realistic depiction of academic researchers over the last decade attacking SGX. Yeah? And just to sort of put that in a more scientific picture, this is a screenshot from the GitHub page of Open Enclave. I think most of you are aware of this project. And you kind of see a continuous stream of vulnerabilities from very early when they went public around 2019 to very recent. And so realizing that enclave software, so there is a moving target. So there is continuously new types of attacks being discovered and new types of defenses that need to be implemented in the software. We sort of want to overcome that moving landscape. And so again, put this in a pretty picture. What TEs originally promised is to have a secure container for application development. And it turned out, of course, that in reality, it's not that easy. And the first type of attacks that most of you, if you have programmed enclaves, might be aware of is pointer level vulnerabilities. So you have to really carefully make sure that pointers lie outside the enclave. More attacks have been shown at lower levels of the system stack. So CPU registers and configuration registers that are shared between these two walls. And of course, the most, I think, tricky attacks that have been shown are the microarchitectural attacks, right? That exploit bugs or shared components in the microarchitecture. And the overarching insight here is that all of these require or commonly require patches in software. Also, the microarchitectural attack landscape at the start, there was maybe this idle hope that this could be all handled transparently in software, in hardware, but more recent attacks, including LVI and Spectre and so on, require at least partial patches in software as well. And so that sets the scene. We need a way to validate that software is written correctly. We also need a way to sort of lower the burden on the application developer. And again, in a metaphor, what we want to do is to help the application developer bridge this treacherous bay securely from one side to the other. And that's where enclave shielding runtimes come in. So they basically offer a convenient abstraction to the application developer, the enclave application developer, that tries to take care of all these enclave-specific concerns. And I think being at a confidential computing consortium, you're very well aware of this. Many of these now prominent projects that have arisen over the last decade are members of the confidential computing consortium. I'm thinking of things like Gramine, the Intel SDK, and so on. So we have a very big landscape of different types of solutions, each with their own advantages and disadvantages, to do exactly this bridging over to the secure enclave application. And I think part of the contribution of Pandora, of this project, is to recognize that there is not one way of doing this. There is an ecosystem of interconnected software, open source projects and closed source projects that do this. So Fritz made this very nice graphic on the left here that sort of visualizes this in a tree. And just to give you the high level summary, you can do this sort of at the function level by means of software development kits. You can also do this at the language level. Several languages, including Rust, have built-in support for SGX. You can also do this at the level of a full application and then sort of give the library operating system abstraction. And of course, you can also do application development on those. And what we observe is that prior works on validation of Intel SGX enclaves have very narrowly focused on applications that were written with the official Intel SGX SDK. And as you can see, that's only it's a relevant but smaller subsection of the sphere here. And what we want to explore with Pandora is the negative of this landscape, and we want to explore sort of all the other runtimes out there. And importantly, we're less interested. It's not completely out of scope, but we're less interested in doing application level validation, because validating an application gives you one sort of certification of that application, but we want to validate the runtimes themselves, which is sort of the equivalent of the kernel in a normal deployment. So we want to validate those root of trusts at the software level. And the technical novelties we bring to achieve that, to achieve this big negative space, is a new way of loading enclave binaries into a symbolic execution framework. I will come back to that later. And also a way of sort of adding pluggable validation criteria of things you actually want to check. So in the rest of the presentation, I will try to just give you a sort of an intuition of these novelties that we bring. So let's start with this term. I already mentioned it a couple of times, symbolic execution. You may or may not be aware of that. I won't go too much into details, but I think most of you have heard of the idea. So let's say I want to validate that function on the top left. You could use something like a fuzzer, but it might take a very long time before it actually finds this magical number 1, 2, 3, especially if that's a large number. What symbolic execution does instead is it's going to sort of simulate this function. So it's not going to concretely execute it. It's going to executed in a software model of the processor. And every time you do branch decision, it's going to keep track of that and sort of make an execution tree, which you see on the right. So it's going to autonomously explore and see that the whole space fits into two buckets with two different constraints on the if branch. So it's going to execute it once with a pin that is equal to 1, 2, 3, and once with a pin that is everything but 1, 2, 3. And does that, of course, in the backend with existing tools like constraint solvers. And so one way of, one very nice tool to do symbolic validation is Anger. Anger is an open source tool to do symbolic execution at a binary level for x86 and a number of other architectures, and it's written in Python. And so that's what we started using as a base for Pandora. Also, just to be fair here, we were not the first to use Anger to explore SGX enclave. So other works have done that. The most important ones are in the table here. This is a screenshot from the paper, which is publicly available. But without going too much into details, the main difference again is that they are very narrowly focused on application validation on the Intel SDK, and they also focus on, again, a rather narrow set of bugs they want to catch. And I think it's fair to say these tools are definitely valuable for catching bugs, but we're not really designed to what we call principled to sort of give you a type of guarantee when you would complete to a certain depth. And Pandora tries to overcome that both by being applicable to a wider range of runtimes and by giving you certain principled criteria to check. So just again, to set the scene, what is it that we have in mind with Pandora, had in mind when we started, is to not just make a nice academic tool, but also to make something that we hope will be used, that is usable to the extent that's possible, of course, within an academic project. So we fully open sourced this. I will get back to that later. We chose to do validation at the binary level. That's interesting because some prior works have done it at the source code level, and we found a number of bugs. For instance, one very tricky bug that was introduced by the compiler. So again, doing it at a lower level is interesting from a security perspective. We also hope that Pandora is not just a sort of a one-off tool, but more of an infrastructure to allow different tools to be built on top. And that's why we have this. From the start, we had in mind that we don't want to focus on one runtime, so we want to extend in terms of runtimes. We also want to extend in terms of what we call plugins, so the actual validation criteria. We hope that, I showed you earlier that there's a number of different bugs and different requirements on software, and we want to catch as many as possible on that level as well. And ultimately, that's something that's more maybe still researchy, but ultimately we also hope that we can even abstract over architectures. For instance, we have recent results here in Leuven where we did the same on a 16-bit processor, so that it's not just x86, but it could be different even instruction architectures. And as I will come back to later, we hope that we can give you some sort of principled validation when the tool finishes, which is better than just bug finding. This is just sort of a sneak peek of how the tool looks. So this is the command line interface, which shows that it's as easy as just running pandora.py with a binary, and you can give it a number of different options to configure it. And the sort of output that it will spit out looks like this. So this is the command line output. It will give you a summary, nicely formatted of different issues it found. And also, importantly, it will link to human readable HTML reports, which look something like this. And so it has all the information that the symbolic execution tool produces. It can give you a disassembly if you click that open. It could give you the content, symbolic content of CPU registers, and even a full backtrace that tells you how to come to that vulnerability. So we found this greatly useful for ourselves when sifting through a lot of reports, and also the industry partners, where we responsibly disclose the findings, also found this very useful. So again, this is our hope that all the infrastructure can be reused if you want to implement validation for a different type of architecture or bug. So I said that there is these two novelties, so the principled validation and the loading of enclaves. Let's start with the loading and tell you a bit more about what is the challenge there and how we overcame that. So for those of you that have looked a bit at SGX in particular, it's a really weird type of extension, x86 extension, right? So for the operating system, it looks nothing like a normal binary, even if it's sometimes disguised as such. It's sort of by design requires the operating system to be loaded very differently. Normally, the operating system does things like relocations, can write and read to the binary layout as it's loading the binary. With SGX, of course, you have to work more closely with the hardware. So there are certain pages reserved, memory regions reserved to interact with the hardware. Things like TCS is a thread control structure. You need one of those for every entry point in your application. You also have special areas where registers are saved on interrupt. You also have special metadata regions like this SECS and so on. And the bottom line that we observed when we started diving deeper into all this for Pandora is that all of these different projects, the ones that I showed on the screenshot before, many of those who are part of CCC, basically have made their own ad hoc abstractions around that. And so if you look at a binary for, let's say, Grammine, that will be very, very different from a binary for the Intel SDK. It will again be different for Microsoft OpenEnclave and so on. So a challenge that we faced before we could even start doing this work is how are we going to parse the binary? How are we going to make sure that we can load this binary into our symbolic execution infrastructure? Yeah, so that's summarized here in this slide. And so the solution we came up with eventually is that we just execute the binary once, and we're gonna listen in while we execute the binary once with a special tool which we call SGX Tracer. And SGX Tracer is based on the excellent ptrace system call infrastructure in Linux. So essentially, we're going to execute the enclave application once and listen in on system calls it sends to the underlying Linux kernel. If you look a bit more in detail, the system calls that we're interested in is, of course, the interaction with the SGX driver. And essentially, this kind of neat trick allows us to automatically discover when an enclave is being created, and then to listen in on all the pages, both the metadata and the data that is being added to that enclave, all that is being created. So what we do is, while the SGX driver, the Linux kernel infrastructure, creates the enclave by talking to the hardware, we sort of make a shadow enclave and write that to what we call here a memory dump file. And then we also write layout information to a JSON file. And this allows us then to simply parse this information and load that directly into Anger. And we can recreate the exact binary bit identical layout of the enclave with all of this information. And so Fritz wrote a very nice loader that is integrated into Anger to do exactly that. Fritz also wrote a number of extensions to the memory model that Anger already has and makes it aware of enclaves and the region that an enclave occupies in the virtual address space. So we made a number of what I think are really neat extensions to Anger to essentially make it aware of SGX. We also implemented the missing x86 instructions and yeah, that sort of makes sure that we can start executing an enclave in a way that we call truthful. So it will execute the enclave in exactly the same way as a hardware would. So it would jump to the very first instruction in the enclave and not cut corners as prior work has done, because they were interested only in applications that are a much later phase. I want to dedicate a bit of our time also to some ideas that I've been discussing more recently, which is whether the insights and the work we have done for Pandora may be generalizable sort of for the ecosystem in more general. And I think the CCC is maybe a nice place to discuss that. So several years ago, I also had this paper together with Fritz on a case for unified ABI shielding, where we said that a lot of these runtimes in the SGX ecosystem are doing the same work in their own way, right? And I think there's an opportunity possibly for code unification, which comes with obviously security benefits because you don't have to maintain different code bases. And so just to sort of clarify the problem, I think, is that every project has their own abstraction around the hardware representation of SGX enclaves. And one way of overcoming that, I think, is a work that is already done by Fortanix, so the people who did also the integration of SGX in the Rust compiler, where they developed what they call an SGX stream format, which is essentially, I think, very elegantly captures the hardware semantics of an enclave. And the way it does that is by essentially relying on attestation. So the attestation mechanism that's built into the hardware for SGX already sort of needs to know the entire enclave content plus layout. And the way it does that, that's illustrated in the figure from an Intel slide here above. The way it does that is it will have it will sort of interleave metadata sections with data sections and do a hash sum over all of that. So for instance, a metadata section is EAT, so that's the EAT instruction. That's all the information you need to say there's going to be a next page here. There's going to be a page is following. Then you do a number of extends, which contain the data that should be loaded inside that page, followed by another EAT when you're at the end of the page. And if you just sequence that out, you get essentially a .txt file or so with all the data in there. And if you do a hash sum over that, you get exactly the Mr. Enclave, the measure enclave value that is being used in remote attestation. And so the interesting property is that we now also have support for that in Pandora. It's not entirely upstream yet. But the interesting property of that is that we can guarantee that we do symbolic execution on exactly the binary as it is being attested to the remote stakeholder. And that's a property that prior works don't have, because they need a lot of hacks, and essentially they symbolically execute a different binary than the one that's being attested. So I think it's maybe worthwhile to discuss in its own right, but I think thinking about whether all of the open source infrastructure that deals with SGX enclaves could not benefit from a unified format is worthwhile. And you could even think of the driver. The driver could take as input, the Linux driver could take as input a .sgxs file and just load that in. That would be a different type of abstraction than the very low level abstraction you have now in the driver, which is essentially wrappers around the instructions. So you have a system call to do EAT, a system call to do extend, and so on. Yeah, if people have opinions on that, I would be very happy to discuss. If not, I can continue, and we can do that at the end, of course. Yeah, I told you earlier that one advantage of adopting this SGX stream format is that you inherit all of the tooling that already exists. So Fortanix wrote a number of very nice tools, and here you see the info tool that just summarizes an SGXS file, and here you see the point that I made earlier, that the layout of a Grammine enclave differs fundamentally from the layout of an SDK enclave. So for instance, you see Grammine has an unmap page at 0, and then it has a number of different read and executable pages. And you see that's very different for the SDK. There's also a different amount of entry points and so on. So again, all of this complexity is dealt with transparently by Pandora, because it just imports an SGXS file and doesn't care which runtime produced it. So let's go to maybe the more interesting part, which is how do you actually detect vulnerabilities? And that's where this plugin scheme comes into play. So essentially we have that engine component on the left, after the loading phase is done, which is, the loading phase is on the left and the engine component is in the middle. So after the loading phase is done, the engine will just talk to Anger and expose certain interesting events to plugins. So we have this idea of breakpoints, which means that a plugin can subscribe when it's being registered to certain events. For instance, I want to be notified whenever an enclave is being entered, or I want to be notified whenever an enclave accesses a pointer that lies outside its address space, and stuff like that. And our idea is that a plugin could really focus on the essence of the security properties it wants to safeguard, for instance, which typically are invariants. For instance, it could say this enclave should never access memory that's outside the protected region. That would be very easy to express by registering on pointer events and then validating that certain properties are true. And so any violations, again, are reported sort of in an abstract fashion and then automatically aggregated in these HTML reports. So plugins really only focus on the security properties, the invariants they want to validate. Typically, there are only a couple of 100 lines of Python. And so we developed 4 of these plugins. I will maybe in a selected fashion go over a couple of those. So we have that for the level of CPU registers, for the level of pointers, even for these more recent exotic things like memory mapped IO vulnerabilities where pointers need to be aligned, and also for control flow. So let's just say very briefly, what's the point with pointers? This is a very simple example of sort of an echo binary. Echo takes a pointer as an argument and it prints that out. It sort of returns that to the attacker. What could go wrong? Very simple. You point the argument to somewhere inside the enclave, and if the enclave, the software, does not have extra validation logic to make sure that this doesn't happen, it will just print out whatever that is being pointed to. This was a real bug in a very early version of Gramine that we found in research several years ago. So this can really happen. Things are even worse if you think about how do you validate a complex argument that consists of several pointer to pointers. Things get really, really messy very, very quick. I won't go into the details, but you have to check whether the first pointer lies outside. You have to copy it inside. You have to check whether the second pointer lies outside. And this can get very tricky very quick. And again, this is a study we did in 2019, and we found these issues in the whole ecosystem, production as well as research. We classified them in different instances, but essentially these are all pointer vulnerabilities. And so Pandora tries to overcome this full class by having an invariant that attacker tainted pointers. So it has a notion of taint tracking that we build into Pandora. So there's a notion of taint tracking, and it says any pointer that is partially controlled by the attacker should point to unprotected memory. It should point to memory outside of the enclave. We use the constraint solver and together with our taint tracking mechanism to make sure that's the case. That works very well. It has a number of false positives. For instance, you could think of an array index where the attacker controls the index. If on the condition that you do bounce checking, that would be fine. But Pandora would regard that as a false positive, which we catch with a number of heuristics. So there is sort of a best effort, best effort classification for those, which works very well in our experience on many runtimes. Again, the output looks something like this. So let's zoom in a bit on that. You would have an address, and you see that this is partially tainted by the attacker, namely the value of attacker mem at a certain address is used in the computation for the final address, and you see what is the possible range of the pointer. You see that it can lie inside the enclave, and thus you're reading an enclave that's an address that was probably meant to be outside but can lie inside. You can find more details if you would click open the disassembly and so on. Another type of issues lies, I already mentioned that a couple of times, lies at the level of CPU registers. And this is work I've also done with Fritz several years ago, where we showed that this can get very tricky very fast again. So you would have a lot of registers in modern x86 processors related to vector instructions, FPUs, and so on.
Maybe we're already at half an hour. So I don't know if Dan wants to ask a question or if whether That's just a polite reminder of the time. So let's maybe skip to the results or speed up into the results a little bit. And then I guess we also have some time left a little bit for some questions if there are some on how to use Pandora or what it can be used for.
That sounds great.
Yeah, and I was by no means being polite. I try to avoid ever being polite. I just had a question. In one of like the verbal list of things before you went into these more specific examples, you mentioned that you could trap on the enclave requesting or following a pointer outside of its memory space. And I'm curious what that event looks like that you're able to actually trap that.
So this relates to what I briefly mentioned in this slide. So there is an enclave, symbolic enclave memory model inside Anger. That's something that we added, that Frits coded. And the way that looks is that every time when a memory address goes through the sort of through Anger's memory bus, Anger has also a memory bus, it simulates a processor. So every time it goes through that, Frits wrote a piece of code that checks whether the pointer falls inside the fixed range of the enclave. An enclave in SGX is a fixed subset of the virtual address space. If it falls in there, and you use a constraint solver for that, because it could be a symbolic address. So if the constraint solver can tell you that for sure in all of the cases, I cannot find any counterexample where it does not fall outside of this range, then it's a protected address. Then we know for sure it's always inside. If the constraint solver responds that there are cases where it falls outside as well as inside, we trigger a certain breakpoint. If the constraint solver says it always falls outside, we trigger another breakpoint. And enclaves, plugins can subscribe to any of these breakpoints. And so the classification of where it falls happens in this memory backend. And plugins can just subscribe to any of these breakpoints and validate certain extra criteria. Does that make sense?
Yeah, it does. Thank you. And now I know that Frits wrote that, so I can go pick his brain later if I want to dig in deeper. Yeah,
the code is also fully open, so you're very welcome to look at the code and even have critical comments or pull requests. We're happy to do it. I think Frits is right that we're running short on time, so I'll just skip to the results, which are here. I won't go into details, but you basically see that we found a number of issues in number of runtimes all over the place. That was our research hypothesis, right? So that's for us, that's good. And I think also for the projects, because we responsibly disclose this and so on. And sort of in conclusion, I will point you to this github.com Pandora TE, where we want to host this project and where it's there. And the key novelties is to do this for the first time, I think, truthfully, so really following the behavior of the processor, that really led to very tricky bugs that other tools could not find, for instance, in initialization logic. To do this in an extensible fashion with plugins. We also have some work on, as I mentioned, on doing this even beyond SGX. And yeah, I think there's still plenty of bugs to be caught in the whole ecosystem. And hopefully Pandora can help to some extent with that.
And maybe to pitch in on the last sentences there with some of the kind of additional words. Like our conclusion of the whole project, I think to some degree, is that it is indeed practical to run some sort of automatic validation on, let's say, important and core pieces of the code regularly, right? So the runtimes that we talk about here, where I think the longest run I did was like 8 hours, and what was it, 60 gigabyte of RAM or something like that, just because we didn't have a bigger machine. But if you take a bigger machine and let it run for a day, I think you can get to reasonable big coverage for these small pieces of TCB that are as crucial as enclave entries or important pieces of code that do all of your legwork. Of course, if you then go deeper and deeper into your application, if you have some actual Linux running in there or something, of course, that's gonna be very quickly be a situation where you have to deal with state explosion. But for your important entry pieces, your low-level code parts, it is very feasible to let this run once per release or every few weeks or so, with a very conservative for 2024 standards budget. And so we hope that this is either a starting point or even just a tool that you can already use, but at least some initiative to talk about. You can do more nowadays than maybe you may think of when you hear the word state explosion. So these things are not impractical anymore, and at least for some core pieces you can run them.
Related to that also, we did find, and the details are in the paper, we did find a minor regression in Open Enclave where an issue that we reported in prior work around 2019 was patched. And then with Pandora, we just discovered that it was unpatched by accident when patching another issue. I think that's, in our opinion, that's strong evidence for what Fritz outlined, that on release you could just run this as part of your validation and catch any regressions.
Exactly. Right, thank you, Jo. I'm happy to open this for discussion if anyone has questions, and otherwise I think he's there. I put the email in chat and check out the repo. Alec, go ahead.
Yeah, this question is coming more from the perspective of a plumber rather than a researcher, but I'll ask it anyway, and you can tell me whether or not it's appropriate. I have contact with some of the folks who are committers on OE, but I'm not clear from the presentation on the paper, just because I don't have the technical depth to understand it, whether this, whether Pandora would help with OE committers, or whether it would only help with the artifacts that are built using OE. I mean, I'm thinking, okay, so fine. If you're an OE committer, I'm sure they have test suites that run and produce applications that are built using OE, and they could run this on the applications, but I'm not sure if that would just find flaws in the testware or if it would find flaws in OE itself.
Yes, that's an excellent question. If I get your question, well, if I understand your question correctly, I think the answer is yes, you can find issues in Open Enclave itself, and we're less interested in validating applications built on top of Open Enclave. There's prior works that arguably are better suited for that because they just they sort of dedicate the computational load more towards the application by skipping the runtime itself and sort of assuming that Open Enclave itself is secure and will be coded well. We do the inverse, and we do the negative of that space, and that's what you see in this slide. So there is a number of applications, for instance, the more recent Signal applications are built on top of Open Enclave. We didn't run those. We ran the sort of the core Open Enclave itself, and we found several issues in there. So I think Open Enclave is a nice project. They have tests, but those tests are more unit test fashion. What I think Pandora can do is more principled in the sense it's also less maybe performant, but in the sense that they just test that the entire code base fulfills a certain invariant. And we found several violations which we reported and got fixed in Open Enclave using that type of, let's say, validation methodology. Does that answer your question? Is that a correct understanding of your question?
I think it did. And let me ask a practical follow-up question. You threw some findings up there that included Radhika's contact information, some of the CVEs that were found. I'm wondering if you've been in touch with Radhika already, or if maybe I could facilitate an introduction.
I didn't catch the name. What is Radhik?
Radhika, sorry. Some of the CVEs that you mentioned that Pandora found in Open Enclave, she responded to those CVEs in the public statements. That's Radhika, and I didn't know if you'd contacted her based on those findings, or if you've never had occasion to mutually be introduced.
We had, I don't know, Fritz, if you remember the name of the people, but we had excellent communication, I would say, with Microsoft people. The issues got resolved. I think communication was clear. So we've had...
Yeah, so I actually met her at CC Summit. We haven't chatted before, indeed. But I finally met her at CC Summit, I think if you can make the introduction to you, it would be, I think, always appreciated to just say hi. But CVE wise and reporting wise, that was kind of just via the open channels and via the visual parts.
Sure, makes sense. Makes sense. Well, I'll forward the paper to her just for her reading pleasure and facilitate an introduction. Thank you.
Thanks.
This has been a great presentation. A lot over my head, but I enjoyed it nonetheless.
Glad to hear.
Yeah, so it's sort of like a related thing that stuck out to me. I thought it was cool to see not just Open Enclave, but Gramming and Keystone, which are also CCC projects. Another project that I didn't see on here that's kind of like a cousin of Gramming is Oaklum. And I wonder if they would be interested as well. So
Oaklum is on the was in the list there. Oaklum is in there.
Was it?
Yeah, we also have it in our table. I'm skipping to that. So we found I think we looked at Oaklum for a little bit in the left column, but we only found derivative issues that were already sort of fixed in the Intel SDK database. I think the problem is that's a limitation I think we should acknowledge. Pandora uses symbolic execution, which has state explosion, and Oaklum, we tried very hard to go deeper, but you have to first go to Intel SDK and then. But it's a nice project, I think. It's definitely in the scope of what we look at. We have in the past reported to them a CVE, a vulnerability they had, which we found with manual source code revision. So yes, I think that it would be interesting to look at it more systematically with Pandora, but it would need probably some novel tricks.
And to maybe also bring that part up. So I don't know if the situation is different nowadays, but we are now not actively working on Pandora anymore. So I moved to NVIDIA. I think you is onto other projects. That's a typical thing with academia, is that you write a paper, you try your best, and we also tried our best to make a tool that actually works and that you can actually run. But then afterwards, there's not much in it for academics anymore. Then so we move on to different projects. But if there is interest from the community, for example, to actually use this, to build on it, to reuse it or something else, we also talked about this, and we are happy to, I don't know, support it or talk about bringing it into the CCC if there's people that want to use it or something like that. I think we had different discussions on similar things like this before, but that doesn't make sense if there's no one that would actually want to use it, right? So we're very happy to discuss this and see if shopping around, if there's someone that wants to build this into the pipeline, extend it and look at it. Or even if we don't want to go that far, just to like look at issues and help support it, right? So there's definitely, if there's interest, please let us know, and we're happy to discuss it.
Yeah, fully agreed. In terms of research, I am looking with some master students. So yeah, there's limited manpower or people power, let's say. But I do hope to continue doing research on this. Of course, research goals are somewhat different sometimes, but I'm very happy to look together if there's an industry partner who wants to do some concrete things here. Invitation is open at any time in the future or now.
Yeah,
also,
I think that's really interesting. So Sal is our technical community architect, and Sal is on the call right now. But we kind of look for things where we can maybe help do some matchmaking in the community. And since this project touches, I guess, 4 different CCC projects, it might be nice to see if we can kind of get everybody either in pairs or in a collective meeting and talk about if there might be some joint interest in maintaining this through the CCC.
I would be very interested to, even if it's just exploratory, sit together for that. Also, maybe for some context, I forgot to say that during the talk, I recently met the people behind Anger, which is also an open source project from academia. I met them at an academic conference, and they were interested to merging some of the SGX support in upstream Anger. Again, people power, but I told him that I will look into that from September onwards and possibly work together with them to also have some of that supported by Anger, which I think would also be good for the ecosystem. So yeah, exciting developments.
Yeah, that sounds interesting too. And that also reminds me that we had a time of check, time of use tool presentation. I think it was around this time last year, maybe a little later in the fall, from an Intel author. And so I kind of also wonder if that would be interesting to loop in here. It was a very different approach, so it might be just kind of two subject matter related tools, but not close enough in architecture to merge into the same project. But that might be worth dusting off as well.
I would be interested to just hear about it. So if you have a public reference on it, feel free to forward it. Yeah.
Okay. Yeah, I'll make a note to myself.
Thank you.
Okay, and that's probably about time then for this topic. Any last question from anybody? Okay, great. Well, Fritz did not oversell that at all. It's rare that we get a topic that comes in and touches actually 4 of our projects. So I think this was a perfect tech talk subject. Really appreciate you coming in, Yo.
Thank you so much.
Bedankt. Did I get that right?
Bedankt is correct, yeah.
Okay, so on to the TAC goals topic. I see Mingshen is still on. I know over email you had done some thinking about the areas where you're going to be contributing based on your role of leadership within the TAC. And I don't know if you have something that you want to put up or if you just want me to bring up the TAC goals document to talk through something.
Yeah, can you bring that document up?
Yeah, let me share my browser again. Okay, so yeah, go ahead.
Yeah, I put 2 objectives under my name. So I'm now saying I will lead the 2 objectives in the next half because I think we can contribute some of the items, but not all of them. The first is we engage the academia to encourage a public-size CC research and study. I think for this goal, we our team at TikTok doing research as well. We have connections with academia in confidential computing another area. So I think I already have some candidates in mind so that I can invite in the TAC meeting to present their like research ideas, initial ideas, all published papers. So that's one part I can contribute. And another thing in my mind, I'm not sure whether we as a CCC can help the academia is usually for the academic like PhD students, graduates, they have no access to the hardware like Intel SGX, TDX, or NVIDIA H100 CC with CC capability. So I'm not sure whether we as a tech in CC can provide those to the hardware experiment equipment to the academia. So that's one topic we can discuss. And yeah, this is one in this objective. In another one, the projects, right? So we have like presented a data clean room project, but still the donation process is a work in progress in both ends, I believe. So in our side, we still need to go through our process, and we will after going through the process, we will like polishing the project and make it more like open source friendly documentations. So we're also considering bring new projects in CCC community, but it's still under discussion. So that's the other objective. Besides that, I think last time we discussed attestation business models. We also have interest to contribute that both in the the documentation or the working group, but now I think it's still in discussion. So and we do have ideas. This has been presented in the Confidential Computing Summit about using zero knowledge proof to do remote attestation, attestation verification service. But I think this needs more discussion in the TAC meeting, and probably is related with attestation mode, business model working group as well. Yeah, that's all from my side.
Okay, cool. Let me rewind you back a little bit. You mentioned for the interaction with academia, I think did you suggest that maybe we could make hardware available to academic projects? Is that?
Yeah, that's true. Because we for example, like we have summer interns working from academia, like PhD students. The main one of the resources we want to ask from the company during the internship is the access to the hardware to do some experiment. So after the internship, we as a company cannot provide access to that, but still as they do research, they need the hardware. Some lab they have their equipment, but I don't believe a lot of labs they don't have this access. Even for me, previously when I was a PhD student, I still were hard to get access to these servers.
Yeah, I think that's really interesting. And Yo, as you're still on the line, maybe as a voice from academia, do you think that if the CCC made hardware available for students, that that's something that would be valuable to them?
Yes, I was actually listening in, and I wanted to chime in. I think certainly yes. I think it could also be an equalizer that I think is very valuable in academia, where maybe the more rich labs, yeah, I think this could make a big difference for smaller research groups. I think it's important if you work with academics to make sure there are no strings attached. Like you want to make sure there are no NDAs or something, that it's actually free research. And I mean, free as in freedom. So that's something you would have to think about. But I was also thinking, so you could think about making this available on demand or something for academics worldwide. But I'm also thinking a very concrete challenge that I see in academia is we are trying to implement now as a community for conferences what we call artifact review. So that means that you not only peer review the paper, but also the artifacts, the open source code. So there is a tendency now in the security community to more and more open source the code that belongs to a paper, which is very good and needed. And there, I know a practical challenge is that sometimes the reviewers who need to evaluate that these artifacts built don't have access to SGX hardware, TDX hardware, whatever. So working together with academic community members who are leading those initiatives, I think is also something you should consider or could consider as a very concrete. You could even, I'm not sure, but you could even consider reaching out to the conferences themselves. I'm speaking about using security, ACM, CCS, and so on, and ask them if this could be your sponsorship as part of CCC, that you could say that CCC helped doing artifact reviews or something. again, I'm throwing in ideas here, but I can confirm that giving easy remote access without strings attached to academics will be appreciated.
Yeah, that's great to hear that. Thank you for helping validate that. And I see Thor in chat is also giving that a +1. Fritz?
I like the idea actually with the artifact reviews. I didn't consider that. So when we had the discussion last time on the academic outreach, I think it was Catherine or someone who made the comment that we might also want to sponsor security conferences just to kind of bring out the word of quantum computing and then promote it a little bit. I think if we, of course, big if, but if we can get this hardware support, giving a limited access to maybe researchers, but maybe by B starting first on giving access to these conferences as some sort of like low-level sponsorship opportunity, I think that would be very well received, but also be a nice way to bring the name of the CCC out there. So yeah, if we have companies that can donate, or maybe we can look at the budgets, etc., to see if we can provide servers for all of the technologies out there. As I think that is an interesting discussion that we could start.
Great. So Ming-Shen, I hope it's okay if I just take your good idea there and stick your name next to it.
For what it's worth, I put a link in the chat, secartifacts.github.io, as an overview of all the artifacts evaluation initiatives in security. There is also sysartifacts.github.io, so you might want to have a look at that just as an entry point, or just to have an overview of what's going on in this. I know also, but I couldn't find it immediately. If you want, I can look for it and put it in the chat as well. There is an initiative from, I think it's cross-university initiative, but Berkeley is involved to make some sort of cloud environment where researchers could experiment and reproduce research. And you could also consider putting some of CCC machines in that cloud or something. I'll find the link and put it, and then it's for you, of course, to consider.
Thank you. That's great. And I think I can just kind of, without removing us from the conversation, also kind of just jump and mix it with this budget discussion. So what we need to do in the next quarter is plan out our budget request back up to the board. And one of the things that we've had on the budget is test infrastructure. So we've allocated about $60,000, you'll see there, to the projects, to CCC projects. But by and large, they haven't actually been consuming that resource. So we might equally consider providing a bucket of resources to academic projects like we've just been talking about. I think we need some thought about, from an administrative perspective, what that looks like. If it's just you give people like cloud credits and they can expense that back to the CCC, or if we would try to maintain some remote access to something that seems more expensive. But there's probably a bunch of different ways that we could go about doing that. Saw Ben shake his head like, no, don't do that.
We don't want to be administering cloud infrastructure for our projects, if at all possible. Yeah, we're just not resourced to do that.
Right.
But I think for T research, usually we need representing the researchers. We need the access to the server, like host machine, guest machine, to do experiment. So without physical access, I mean not physical, I mean a cloud is okay, but if we can provide the access to the servers, host servers, which will be very helpful for other type of research in hypervisor operating system. It's my comments. But if you cannot do administration operation on the hardware. I'm not sure whether there's alternative ways we can provide this.
Yeah, on the one hand, I think the hardware is more available in clouds right now. So you could go out to a variety of the CSPs and be able to rent this. And then it seems logistically easier for us to be able to provide some sort of expense mechanism. But you could also envision donating a server to a research group. It's just that, you know, with one server, we could exhaust the whole budget. But I know that one of the advantages of having physical access to a server is that you can operate at the host level, whereas when you go through one of the cloud hosting environments, you're going to pretty much implicitly be inside a VM to begin with. That probably limits a lot of what you would want to do with researching and attacking co-resident VMs.
Yeah, I think it's also probably worthwhile to think about what we might be able to get for free if we approach some of the providers or some of the companies provide these services, right? I mean, the budget of the CCC is always going to be limited, right? But for these companies providing credits, right, it's not like a credit is equal to $1, right? It's often cheaper for these companies to actually offer free credits, a lot cheaper. And on other products I'm on, we've gotten quite a lot of free services simply by asking. So I think if the folks here can put together, you know, what a reasonable ask might be and what companies we might want to approach, I think that's probably the first step.
Sounds great. So maybe in our, I don't know, maybe adjacent to our budget request to the board, we could include something about for those companies that are CSPs, that they offer some budget of credits to the projects and or academics that come through the CCC.
Yeah, I think that's right. And I think on our side, we would want to think a little bit about what we would offer those companies kind of in return. If, for example, we have a partner page on the website that lists the logos of folks who are providing credits, if we wanted to publish a case study or something that shows how we're using that, or even if we want to link to them from our GitHub repos, things like that, like some co-marketing, you know, kind of as a thank you to these folks does sweeten the deal sometimes.
Mm-hmm. And then I think on the other side of the equation, on the demand side of the equation, sometimes just like with the projects, we make resources available and they don't get consumed. So we would need some facilitation with the academic community to make sure that they are aware of it, particularly maybe those less well-resourced research groups.
Yeah, I think that's something we can start doing once we have a good overview of what we can support. Because I think there, yeah, as soon as we throw out a post somewhere, oh, we have money, I think usually that's not the problem. I think we rather want to first do the, let's say, logical or let's say a guarded step of going to conferences and offering that and see if there's interest there. But yeah, I mean, first we probably have to make the homework and go to the board and see if we would get these credits at all and how much it would be.
Yep. Okay. Well, Ming-Shen, thanks for putting thought into this, and I think these look like good result items to attack through the rest of the year. And then just to kind of give the summary view on this again, maybe in the next meeting or the one after, we'll want to put together our budget request for next year. And so besides the test infrastructure, there's the travel budget, which got some use, and it tends to get used by the same couple of projects or people. So we want to make sure that the projects broadly know about this. This is mostly meant to facilitate getting our maintainers to conferences to help get their projects more visibility and adoption. We've pared it back pretty small already, so I don't know that we're really going to save much on a budget request by making that smaller. So I'd rather us maybe make sure that we're using it better. The bigger travel line item was for the community architect role, and that looks like might be over budgeted a little bit. Not sure. And then this somehow seems to continually be underused, this IT services and tools. So I think this has gone through the ringer a few times on what that might entail. I think it includes doing things like license scans, unless license scans are free.
Looking for the unmute button. You are correct. It can be for things like license scans. License scans are not free because it does require a person. It also can be used for town hall type software if you're not using Zoom, if we're using something like a Bevy or something like that. Yeah, pretty much IT service and tools that the LF provides in support of the projects.
Yeah, I wonder if there's some way that we would be able to get project maintainers into the budgeting meetings so that we're getting their voice into this budget. So Sal, that might be another thing for us to think about is if we give ourselves enough time to get in contact with them, maybe we do this budget discussion, not next meeting, but the one after.
Yeah, let's follow up on this on Monday. If I can give them exact numbers and projections to follow up on for next year, I think I can hone us down.
Yeah. Yeah, and I just also want to get their thoughts on what this budget is intended to do in general for the projects is reduce friction for them or help accelerate them. So these are ideas that we have had all along of what would be useful. But if there's other things that would help accelerate the projects, help reduce friction for what they do, we want to get that recognized.
Right. And that is a note for anyone on the recording. If you are watching this at this time, let us know if there's any changes, alterations, or engagements with this budget that you want. Let us know. We are trying to get ready for 2025 as well.
All right, good call out to the recording. So coming up for next time, I put a note into myself. We should check attendance, but we're already getting a little bit skinny at the end of the hour here. Maybe for the voting members that are yet on, so David, Fritz, Alec, Mingshen, I know a lot of people are out in the US for the holiday week, or for getting an extra day of holiday that week. Are any of you planning on being gone?
I will not be here. I will be on vacation, unrelated to US holiday, but I will be on vacation.
Okay.
I'll be in attendance, or I expect to be.
Okay, great. David?
Yeah, I should be here.
Okay, great. By the way, welcome back, David. Nice to have you back.
Thank you. Yep, appreciate it.
And Mingshen?
Yeah, I'll be.
Okay, so it sounds like with that sampling size, we should probably still be able to reach quorum for next session on September 5th. At that time, we'll be getting an update from Yash and or maybe Ram on the mentorship program. So Rian, if you want to ping Yash to make sure that Yash is aware of that. And then it looks like we've got another good tech talk lined up that I think I've seen some of the email traffic around this one. Fritz is nodding yes. And then meeting after that, some people might be gone to Linux plumbers. When we sampled on that before, it didn't seem like too many people from the TAC would be gone, but I know David planned to be there and maybe do a report out on it afterwards, 2 meetings thereafter. Any other items that people want to get up on the topic schedule for the next few meetings?
Maybe just to understand, October 3 is just empty because it's empty, or is it empty because Rosh Hashanah is impacting a lot of folks and we will not have a meeting there?
I think it's an open question about how many people will be gone for the holiday, and it is happenstance maybe so far that we don't have anything on the agenda for then.
Okay, I'll see if we have it like a tech talk scheduled then, but yeah, maybe we just don't have anything there then. Okay.
Yeah. Okay. All right. Well, thanks everybody. Great meeting. A lot of good talks, and look forward to seeing everybody online in the intervening time before we meet again on the 5th.
Thanks everyone. Have a good day.
Thank you.